Hi everyone, welcome back. Today we are going to be working on solving some word problems. Some of our word problems may look familiar to you because we've seen these types of problems before. Let's go ahead and take a look at our learning target today. Our learning target today is I can solve comparing word problems by using a model and an equation. By using a model and an equation. So let's think about what that said. Let's think, what kind of models and strategies have we used in the past to help us solve word problems? Take a minute, hit pause, and when you're ready to share, hit play. That's right, I heard a lot of great ideas. All of those are great models and strategies to use. Let's go ahead and take a look at this first problem and think about what kind of strategies or models you can use. Before we get started, you need to go ahead and gather your materials. If you have a marker and whiteboard, you can use that, or if you have a piece of paper and a pencil, you can use that. You also might want to grab your manipulatives such as cubes or counters for this problem. Go ahead and gather your materials, hit pause, and when you're ready, hit play. Do you have your materials ready? Great, let's go ahead and get started. Now I am going to switch my screen over so that you can see the problem with me. And then we're going to see about how can we solve this problem. On my paper, I have the problem. There were 7 green marbles and 8 blue marbles in a bag. How many marbles were in the bag? So let's think a minute. What do we know? There were 7 green marbles and 8 blue marbles in a bag. How many marbles were in the bag? Think about what we know in this problem. We know that there are 7 green marbles. We also know that there are 8 blue marbles. What we want to know is how many marbles were in the bag. By thinking about this problem, I know that 7 is a part. I know that 8 is a part. So that means the total number of marbles in the bag is that's right, it's my whole. So thinking that you have your 2 parts and we want to find our whole, go ahead on your paper or your board, show me the equation and what model or strategy you are going to use to solve this problem. Hit pause, and when you're ready to share, hit play. All right, guys, I saw a lot of great thinking. So I have my 2 parts, but I need to find out what my whole is. What kind of equation would go with this type of problem? That's right. I would take my 7 and I would add it to my 8 to figure out what my whole is, because we know that we can add our parts together to equal our whole. I saw some wonderful strategies being used. I saw someone use their counting on strategy. They had 7 and they counted on 8 more. Count on with me, please. 7, 8, 9, 10, 11, 12, 13, 14, 15. So they added their 8. So 7 and 8. Let's count and see how much that is. Here's 1, 2, 3, 4, 5, 6, 7, 8. If I start at 7, let's count on. 7, 8, 9, 10, 11, 12, 13, 14, 15. So how many marbles were in the bag? That's right, there were 15. I saw another great strategy that I love to see. Someone used a 10 frame. We know when we're drawing our 10 frame, we start with a rectangle, we slice it in half, and we put 4 lines down. 1, 2, 3, 4. That gives us our 5 on top and our 5 on bottom. If I had 7, and I added 8 more, how many would I have? Well, I know when I added that 7 and that 8, I made a group of 10. So now I have 10, 11, 12, 13, 14, 15. So I still got the answer, which is 15. Another great strategy that I noticed. Someone used a number line. You know how I love a number line. So on our number line, I would start at 7, because that's where I'm starting, and I would count on 8 more. So 7, 8, 9, 10, 11, 12, 13, 14, and I would end up at 15. 1, 2, 3, 4, 5, 6, 7, 8 tops. So I would have 8 at the top when I label. These are wonderful strategies to help us learn. You could have also used a part whole to help you solve. Well, I know my 2 parts. I know that I have 7 and I have 8. What I don't know is the whole. So to help me with that, I have my 7, and I'm going to go ahead and put 8 counters over here. And then I'm going to count on 7, 8, 9, 10, 11, 12, 13, 14, 15. So my whole was 15. These are wonderful strategies to use when you are solving word problems. Now that we have warmed up and we reviewed some of the strategies that we've learned, let's go ahead and solve this next type of problem. Now, we've learned to solve comparing word problems in the past. Now we're going to learn how to do them a little bit more. Look at this problem. Zeke has 12 stickers. Michael has 18 stickers. How many more stickers does Michael have than Zeke? This one's worded a little bit more tricky than our last one. Let's look at it again. Zeke has 12 stickers. Michael has 18 stickers. How many more stickers does Michael have than Zeke? What do I know in this problem? Is it asking me how many stickers they have in all? No, it's saying that Zeke has 12, Michael has 18. And if Zeke has 12 and Michael has 18, how many more does Michael have than Zeke? Thinking about what we've learned about comparing word problems, go ahead and try to see if you can write an equation and solve this problem. Hit pause, and when you're ready, hit play. Great job, mathematicians. I saw a lot of people remember how to use their comparing strategies. So let's take a look at this together. I know that Zeke has 12 stickers. So I'm going to go ahead and draw Zeke's 12 stickers. And a good thing to do is always go back and double check. Check to make sure that you counted correctly. Can you help me? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And Michael has 18. I like to label my problems so that I know who has what. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Again, I'm going to double check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Now, do I add these two numbers together? Did the problem say how many stickers do they have in all? No. So I won't be adding them. I'm going to compare them. I know that if Zeke has this much and Michael has this much, how many more does he have than Zeke? So if I know that he has 12 and he has 18, I'm going to compare them. I'm going to match them up. So I'm going to draw a line to match up what they have that is the same. But wait, there's no more for me to match up. So this is how many more Michael has than Zeke. 1, 2, 3, 4, 5, 6. So I could say that Michael has 6 more than Zeke. So for an equation to match what I did, I could say 18 minus the 12 that I matched equals 6. And I put a box around the 6 because that was the unknown that we found. Now, if we look, we learned some other strategies as well, didn't we? We learned that we could also use a part-part whole to help us. So let's go ahead and think about a part-part whole model. If I were to use a part-part whole model, I know that I'm not going to be adding the numbers together. I want to compare. So I know that 18 is my largest number, so that must be my whole. I know that 12 is how many Zeke had. What I need to know is the difference. And I know the whole, I can minus a part to get the other part, or I can put my two parts together to get my whole. So if I'm at 12, I'm going to count on until I get to 18. 12, 13, 14, 15, 16, 17, 18. How many was the difference? That's right, it was 6. So I could say 12 plus something equals 18. And we found out that that something was 6. As always, when we are comparing or solving any type of model, a number line is always a good choice. So I know that I had 18. And I want to find the difference between 12 and 18. So I can hop back until I get to my 12. And I'm going to go ahead and circle that so I know that's where I'm going to stop. 1, 2, 3, 4, 5, 6. So 18 minus 6 equals 12. And I can represent that by 18 minus my box will give me 12. Because we know we have our whole minus a part equals the other part. Now I could have also used my original equation, which was 18 minus 12 equals 6. I could start at 18. I could minus my 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So when I minus my 12, my answer is still 6. We've learned lots of great strategies to help us with comparing. This one shows me the exact amounts that I can use, and it shows me exactly the difference. I can use a part whole, like I have to solve other problems, to figure out the other part as well. I can also use number lines to help me compare. When we are comparing, we're determining the difference between one amount and another amount. Let's go ahead and try another problem. This problem says, Tracy has 13 basketballs. Crystal has 17 basketballs. How many fewer basketballs does Tracy have than Crystal? Well, let's think about what we know. We know that Tracy has 13. We know that Crystal has 17. I want to know how many fewer Tracy has than Crystal. So in this problem, I can tell that I'm not going to be adding the numbers together because it tells me that I want to know how many fewer this person has than this person. So I'm finding the difference. On your paper or your board, think about what the problem is asking, show me an equation and a model for how you would find out how many fewer basketballs does Tracy have than Crystal. Pause the video, and when you're ready, hit play. Great job, mathematicians. What equations did you come up with? That's right. I can think about Tracy having 13 and Crystal having 17, and I can compare them. So I'm going to use my comparing strategy. I know that Tracy has 13. So I'm going to show her 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And I'm going to show Crystal's 17. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Now, here's what I saw as a misconception. I saw someone say 13 plus 17 equals box. Can someone tell me why would this be a misconception? That's right. It's not saying how many basketballs do they have altogether. It's asking how many fewer does this person have than the other person. So this would be a misconception. We're not trying to add the numbers together. We're trying to find the difference. So if I'm trying to find the difference, I would match them up. And when there's no more to match, I circle what's left. And I know my answer is 4. Now, if my answer is smaller than my other two numbers, what does that tell you about your equation? Are you going to be adding or are you going to be subtracting? That's right, you're going to be subtracting. So since I'm subtracting, I always put my biggest number or my whole first. My whole would be 17. So 17 minus the 13 equals my 4. And since 4 is what I was trying to find, that would be my box. I saw some other strategies being used as well. Someone did a part-part whole. And if we're using a part-part whole, what would be the whole? We always know that our whole is our largest number. That's right, our whole would be 17. What would be the part that you know? That's right, it would be 13. I know that I can add my two parts together to get my whole. So I could say 13 plus something equals 17. So let's see what that number would be. 13, 14, 15, 16, 17. And what would my answer be? That's right, it would be 4. Great thinking, mathematicians. I saw one other way that you could have solved this problem. Someone used my favorite, which is a number line. If we were using a number line, I know that Crystal has 17, Tracy has 13. I want to know how many fewer Tracy has. So I'm going to start at 17 and I'm going to end at 13. And I'm going to see how much was the difference between these numbers. So I'm going to hop back. 1, 2, 3, 4. So 17 minus 4 equals 13. And since 4 was my unknown, I put it in the box. Great job today with your comparing word problems. Remember, sometimes when you're comparing, you will be subtracting, and sometimes when you're comparing, you will need to add. Comparing means you're comparing two different amounts. All right, guys, thank you so much for participating in our lesson today, and I will see you next time. Have a wonderful, wonderful day. Bye-bye.